by coming to this stage, we are coming to our projects. So we have just finished with the theoretical part, which involves a lot of mathematics, equations, terms. But now we come to actually our project. It will be explained briefly and very fast over here. All right. So this part, because since we are designing a quadcopter, which is using RL to, to compare it with the PID controller. So we start with building this kind of environment, which luckily it is provided, in MATLAB environment. So you don't need to do a lot of job to understand the concept and just to recognize few factors and little changes can be used. Then just train the environment with the agent. So yeah, it is provided in the MATLAB. The environment is provided, so we just insert this kind of environment. So in this part, shortly, to make it fast, we added this wind function to our system, the PID system, with the observation block, with adding reward function, and yeah, in the very coming week we will try to improve the system. And here we are showing some of the results we were having with the implementation of RL. So as mentioned, we have this block parameters RL agent provided in the MATLAB environment. So we'll just insert it with this kind of agent objects, and following the steps, we'll come out with this kind of functionality with adding some other parameters. How much episodes do we want? How many parameters do we want? How many layers do we want it to be? All these can be used, and yeah, and which methods, which algorithms, such as we use DQN, which is deep Q network, neural network. So neural network parameterization and few factors here will be added. Then the block will be there. Yeah. So very important part also, which is building the structure of the neural network, which is also provided in the Simulink, and that is very helpful. Not a lot of things to be done, but it is very essential to understand how to, if required, nowadays, we are not required to modify it too much, but this is how does it look like. What we did in our design is design the reward function, and yeah, we go for training to see how it's going to be. So with the RIS reinforcement learning, we tried to train this system. Actually, it takes a long time. I don't know, is it my computer slow? If there is any leakage in terms of this kind of functionality, but in general, what I read in these blogs and what I read in the articles, generally it takes a long time to estimate the best state and the best actions to be done, so to get best rewards. Yeah, but then I have reduced some parameters such as the epsilon learning value, changing here and there to make it faster. But generally, it is good. It is, good results. So with designing these blocks, we can also get MATLAB code from this blocking. Can be generated out this kind of codes directly. The MATLAB will provide this kind of blocks, and these kind of classes and functions can be just called by another functions used previously with the PID controller to get some good result, to make it easier for us to design. So this is our system over here for the Q learning, the neural network controller, which is having RL in here. We have observation block here, and the calculation rewards, the function of the rewards over here. And here is the complete system so far. Here is our environment. Here is our quadcopter. Actually, it is the quadcopter block diagram. Yeah, and here is this RL, these previous functions, and here is the wind. We have added this wind block over here, and here is the error generating signaling for the block diagram and observing the results to be combined with the RL block over here. Yes. Finally, let's go and run our simulation. Let's see how is it going to be. This simulation. Actually, there are two videos. Each video is 5 minutes, but these are results of about 8 hours. I think maybe between 4 to 8 hours. Okay, because I each like 2 hours. I take like a very short observation and I stop recording. Then after 1 hour, I can record like 1 minute and like that. So here is the training for this agent. So it started with minus 1.5 average reward. Here, sorry, episode Q0. So the best episode is minus 0.5. Started with that, and then it keeps under 0 because it is keep learning, which is very important in this graph. Is here epsilon Q0. So other graphs over here represent, I mean, the blue one represent the values, the rewards values, and the gray color here represent the average of rewards values, and the important one is the yellow or the orange part here, which shows the training behavior of this according to these rewards. How does the system behave? It is under 0, which means it is getting more penalties than to be a positive rewards. But after some times, it gets higher than 0. For this first video, actually, I've just set the values until 5,000. So until it reaches to 5,000, it gets the best Q0 is 0.3, which is good, but it needs more training to get better results. So the next video, I think I have got, yeah, I've got a better result for the second video, which I'll be showing later on. So here is the continuity for the second video because I stopped the previous video and increased the. So you see here, it is getting upper than 0. But after like 5,600 episodes, the results gets learning, very good learning, and it is very amazing to get this kind of learning. It is not even just doing positive, but it is getting higher and it levels so fast and higher rewards. And someone I will show here, I mean, comparing to the previous facts, you see in the very early stages, they are up and down. I mean, here you see the circles, the rewarding, they're getting almost balanced. I mean, like here rewards and 150 penalties. So it is getting, yeah, reward and penalty, reward, penalty. But after sometimes most of the rewards are higher than the penalties. I mean, the quantity of the rewards is higher. You see here a lot of rewards and quite few penalties. So that's why the system is doing much better. Average of Q0. Again, this Q0 is the optimal value wording stage with the best states and actions. This is the translation of Q0.